Welcome back. It's time to talk about this diagram that looks a lot more complicated than it actually is. The JavaScript runtime. Since, as we mentioned, JavaScript is a single-threaded programming language, it has only one stack and one heap. Hence, if any other program wants to execute something, it has to wait until the previous program or function is completely executed. And if I do something that takes a really long time, well, things are going to be really slow for our program. That's not good. Boo, that's not nice, is it? We don't like that. And this is where JavaScript runtime comes in. In this case, the web browser is working in the background while the synchronous JavaScript code is running. And it's using something called the Web API or the Web Browser API to communicate and let the JS engine know, hey, I'm back with some data, some work that you told me to do in the background. Let's dig deep into this topic. The Web API comes with the browser. Chrome, Microsoft Edge, Safari, Firefox. All of them have their JavaScript engine implementation, and all of them have a JavaScript runtime that provide a web API. These web APIs are applications which can do a variety of things like send HTTP requests, listen to DOM events, maybe click events on a DOM, delay execution using something like set timeout, can use set interval. It can even be used for caching or database storage on the browser. Let me show you what I mean. If we go to the console here and I look at the window object, well, this is what the browser provides. This is the web API that we can use. So that if I scroll down here, I can see different things that the browser provides for us that our JavaScript engine can use. For example, if I scroll down to, let's go to fetch. Fetch, that is the function to make HTTP calls. We can use that. If I keep scrolling down, and let's look at something fun like indexed.db or indexedb. That's actually a little database that we can use on our browser. If I go to application here, I see that I have some storage and indexedb that the browser provides for us. Very cool. If I keep scrolling down, I also see something familiar to us, such as set timeout. Let's see, where is it? Right here. Set timeout, set interval. All of them are provided by the browser. They're not native to JavaScript. So remember that the browsers are helping us create rich web applications so that users aren't just sitting around waiting for our JavaScript to execute. Anything that can be offloaded, they'll take care of that for us in the background. Because you can imagine, if the browser had to use the same JavaScript thread for execution of these features, well, it's going to take a really long time. So browsers actually, underneath the hood, use low-level programming languages like C++ to perform these operations in the background. And these APIs are called web APIs because, well, they're APIs provided by our web browser. And these web APIs are what we call asynchronous. That means you can instruct these APIs to do something in the background and return data once it's done. Meanwhile, we can just continue working on our JavaScript call stack and execute functions. So what are these other two things? Now, we're only going to scratch the surface here because towards the end of this course, we have an entire asynchronous JavaScript section. But this is what happens underneath the hood. We have items on the call stack, and as soon as something comes up, like set timeout, that's not part of JavaScript, it's part of the web API, the call stack is going to say, oh, I have something that's not for me here, it's for the web browser, for the web API. So it's going to say, hey, web API, here it is. I don't know what to do with this. You take care of it. The web API is going to say, I know what set timeout is. Let me take care of that and do that in the background. Now, with set timeout, you usually want something to happen afterwards. So once the web API is done working on it, maybe it's fetching some data from a server, it's going to say, all right, I'm done with this work. Here's the data, and here's perhaps a callback of what I want you to do with that data. And then the event loop is going to say, as soon as the call stack is free, is going to say, hey, I have something for you here. Would you like to add it onto the stack? And if the stack is empty, it's going to push this callback onto the stack. But that's kind of confusing. Let's actually code this and demonstrate how it works. Imagine we had a console.log, and in here we'll just print 1. And by the way, this is a really, really common interview question, so hope that catches your interest. And let's say we'll also do set timeout, which is part of the web API. And in here, we'll just give it a function, and we'll just say console.log 2 in, let's say, 1,000 milliseconds or 1 second. And then console.log 3. Now, if you've been working with JavaScript for a while, this isn't difficult. You know what's going to happen. But just to go over it quickly, if I go to my browser here, let's copy and paste this, and I run it, I get 1, 3, 2. Why is that? Well, it's because we added console log to our stack, and we logged onto our console, and then we removed that call from our call stack, and then we went to the next line, set timeout. We added this onto our stack, and then immediately the JavaScript engine is going to say, oh, set timeout, that's a web API. I don't really care about it. I don't know what to do with it. I'm going to just send it off to the web API. So this gets moved away from the call stack and gets sent to the web API. Now, we don't know what's happening on that side of things, but we just go to the next line and say console.log 3. It's going to log 3. Now, behind the scenes, the web API is going to take the set timeout. It's going to start a timer that is going to run for 1 second. And once that 1 second is over, it's going to push the callback. That is, what to do once it's done running for 1 second. And the callback in this case is console log 2. It's like it's calling us back saying, hey, we're ready for you. 1 second has passed. Can you console log 2? And what happens now, the console log 2 goes to the callback queue. Let's go to the diagram. Goes to the callback queue and says, I'm the first person that's done. Can you console log 2? The event loop is a loop that's constantly running that's saying, hey, is the call stack empty? Is the call stack empty? Is the call stack empty? And the event loop only runs once the call stack is empty and the entire JavaScript file has been read. In our case, console log 3, no matter how fast the web API responds, adds the console log 2 to the callback queue, the event loop won't start putting anything back into the call stack until the call stack is empty and we've run through the entire file at least once. So in our case, after console log 3 gets printed and popped off the call stack, the event loop is going to tick and say, all right, can you console log 2? And that's why we get this weird pattern. Now, Philip Roberts, who has an amazing talk about the JavaScript event loop and this whole JavaScript runtime system, created this tool to actually visualize this a lot better than I could explain. We're going to go over the same steps that we just did. We see that we have function A that calls function B that calls function C, and function C that calls set timeout. That's a web API. And it's going to have a callback function that is, once it's done running for 3 seconds, call achieve nirvana. And achieve nirvana is going to console log you are enlightened. Let's see what happens. And before I click play, see if you can predict what's going to happen and to test yourself. Let's have a look. So we see right away, A gets called. That's the very first thing that happens because up until now, we've just declared functions and we only run on line 17. That is, we execute function A. So function A gets executed and we call B. So we add that to the call stack and then we resume, call C. That gets added to the call stack and then C gets called. That is, we add set timeout to the call stack. And what do you think happens here? Well, set timeout now gets sent to the web API because, well, it's a web API. And we don't really care what the web API does with this. It has its own implementation. But in this case, it's using this timer to just run for 3 seconds so that it can add it to the callback queue. But in the meantime, our JavaScript engine doesn't care what's happening. It's just going to keep working on the call stack. So if I resume here, you'll see that A, B, and C all get popped off the stack while the timer is running. Now see what happens when this timer ends. I'm going to resume, and look at that. It finished in 3 seconds, so it's going to put it back or put it into the callback queue. And the callback queue is going to say to the event loop, hey, can I come back to the stack? I'm lonely. Can I come back to the stack? And the event loop says, hold on, let me check. Is the call stack empty? Yes, it is. Has the entire file been run? Yes, well, line 17 is the last line. So that's the last thing that we want to run. Okay, you're allowed to go back on the stack. So I'm going to resume and look at that. The achieve nirvana is going to get popped or pushed onto the stack. Console log gets printed, and then we pop everything off the stack. Congratulations, we've just achieved nirvana. That's not too bad, is it? Now, here's a fun little question for you. What happens if we do the exact same thing, but this time add 0 here? What do you think will happen? Well, if I run this, I get 132 still. Now, like I said before, this is a very common interview question. The reason that happens is that no matter how fast this set timeout timer happens, it still gets sent to the web API, still gets sent to the callback queue, and the event loop still needs to check those 2 checks. Hey, is the stack empty? And has the entire file been run? In our case, no, we're still waiting on console log to run. And only then will I push our callback function, our console log, to our call stack. How cool is that? And using this method, we're able to have this power of asynchronous code. That is, instead of being limited to one call stack and one memory heap, whenever we get tasks that can be asynchronous, that take a long time possibly, like modifying DOM or making HTTP requests. Well, in that case, we can just send that off to the browser. The browser can just run that in the background. And whenever we're ready, it can just use its callback queue and event loop to notify us. All right, that was a long one. Let's take a quick break and I'll see you in the next video. Bye-bye.